All right, welcome to the lesson on midpoint formulas and the distance formula. All right, our first iteration of this is the midpoint on a number line. And again, we're talking specifically about a line segment. So let's say this is segment AB right here, midpoint of segment AB. All we need to do is find the mean, and the mean is just the fancy way of saying the average. We add our two numbers together and then we divide them by 2, and then that's how we find the midpoint. So let's give it a little bit of practice. So we're saying line segment AB, so in our heads we say line segment AB, there's A, there's B. It has endpoints of -4 and 9. So here's -4 and 9. And again, -4 is smaller than 9. That's why it comes first, farthest to the left. That's why it's point A, and that's why 9 is point B. We want to find its midpoint. So basically what we're doing is just saying -4 plus 9 divided by 2. -4 plus 9, it's the same as 9 minus 4, which is 5 over 2. That's right there is the midpoint. Just like that, half of 5 is also 2.5. So our midpoint could be either 5 halves or 2.5, same number. Now here we have something a little bit different. We have the midpoint of AB. I'm going to draw a line AB again, AB, switch some colors, and say it is at 10. This is 10. That's our midpoint. Again, approximate, of course. That's our midpoint, though, specifically because that's where I put it. And we're saying A is at -12. All we have to do is kind of work backwards. We know that A plus B divided by 2 gives us our M, or midpoint. So what I'm going to say is 10 midpoint equals -12 plus B divided by 2. Now to work with this, I'm going to shrink this up, move it over, and let's continue to work with this. The first thing I want to remember is I need to isolate my variable B. To get rid of it, I have to get rid of all the stuff that's messing with it, as I like to say, all the things that are involved or engaged with it. The easiest thing, and order of operations says to do it this way, is to get rid of this divided by 2 first. So I just think to myself times 2 on this side, times 2 on that side, and then I say 20 is equal to, it just, again, it's they cross reduce to 1s. The identity property says that 1 times -12 plus B is -12 plus B, so I say 20 is -12 plus B. I then say capital B, because that's what I have up there. I then say plus 12 to each side, and I get 32 is B, and that is my answer. I have my other endpoint at 32. Now let's check that for reasonableness. I'm going to jump in. I'm going to say, here's my 12, -12 as A, and then here's my, what I'm saying is going to be 32 as B. And I think about how far away is 10 from -12? Well, 10 is 10 from 0, and another 12 from -12. So it is 22 away. How far away is 32 from 10? Also 22 away. So sure enough, we have found our midpoint. Now, the coordinates of a midpoint on a number line are just very straightforward and easy. On a coordinate plane, it's a little bit different. We have our formula here, and if you look real closely at our formula right there, and again, I should have M equals, midpoint equals. And all we're doing is finding the mean of our x coordinates. We call that x1 and x2. And then the mean of our y coordinates, y1 and y2. Now I'm going to get rid of those marks so we can look a little bit more clearly. Apparently I'm not. But the idea is we just have to plug this stuff in exactly like we'd plug it in any other equation. Just because we have these little fancy subscript 1 and 2 doesn't change anything. The formula is midpoint is x1 plus x2 divided by 2 for our x coordinate, y1 plus y2 divided by 2 for our y coordinate. Now let's give that some practice. Line segment EF has endpoints at 7, 5 for E and 2, -4 for F. What we first want to remember is the smaller x value is always our quote-unquote first point, because we read lines from left to right, line segments from left to right on the coordinate plane. That's just how we read them. So this is actually going to be x1 and x2. X1 and y1, I'm sorry, x1 and y1, which makes this x2 and y2. 2, our second point, and that's what the subscripts 1 and 2 stand for. It's just saying first point's x coordinate, first point's y coordinate, second point's x, second point's y. So I'm going to go ahead and set up the formula. Again, all we're looking at is I'm going to just use blue for our x's, and x1 plus x2 divided by 2, so that's 2 plus 7 divided by 2, and then I'm going to say y1 and y2 divided by 2, and that's negative 4, comma, y2 is 5 divided by 2, excuse me, that should be a plus, my bad. So now we have 2 plus 7 is 9, half of 9 is our x coordinate for our midpoint 4.5, and negative 4 plus 5, same as 5 minus 4, just switch those around in your head. That's 1, half of 1, or 1 divided by 2 is 0.5. So we go right 4.5 and up 1/2, and that's going to be the midpoint of our line, EF. Now, here's the same thing that we looked at with our number line. The midpoint of CD, we're given the midpoint and an endpoint. If we're given the midpoint and an endpoint, we just again have to kind of work a little bit backwards to find our missing coordinate. So again, in this particular case, I look at CD, I look at the midpoint of CD having a negative 2 and one of the endpoints having a negative 5. I know that negative 2 is larger than negative 5. So in this particular case, I'm going to call this x1 and y1. The reason being, I need to just keep my ducks in a row and keep my thoughts straight as I'm approaching this problem and filling stuff in. I still don't know what x2 and y2 are, but I'm here to figure that out. Now, again, look up here at the midpoint. This is negative 2 for my x variable and 1 for my y variable. I'm just going to go ahead and plug that in. I have negative 2 equals, and my y is 1 equals. Then I have to plug in what else I know. The only other thing that I know is that my x is negative 5 and my y is 7 for my x1 and y1. My first point, furthest to the left, so I'm going to plug that in too. I'm going to say negative 2 equals negative 5 plus x1 over 2, and 1 equals 7, which is my y1 plus y2 over 2. Now from there, I need to shrink this down, move it over. All I need to do is solve. And again, same idea, times 2, times 2. Really on both of these, I'm doing the exact same thing. I'm going to use that 2 in both places. That's kind of lazy, but I ran out of space. So here we have negative 2 times 2 is negative 4 equals negative 5 plus x1. And 1 times 2 is 2 equals 7 plus y2, because again, these cancel out and these cancel out, whichever way you want to look at it. Now I just have to finish out my processes. I just add 5 to each side, plus 5 over here, plus 5 over here. I subtract 7 from each side, minus 7, and I end up with my x2, which is negative 4 plus 5, that is 1. And I end up with my y2, which is 2 minus 7 is negative 5, and that is y2. Now all I need to do is put those in the correct position, 1 comma negative 5. So to find my other endpoint, I go to the right one and down 5. And I encourage you to put this on a coordinate plane if you have one available, just to double check. I always do. I draw one. I enjoy that process. I think math is fun. It's a good time for me. And if you enjoy that process too, go ahead and do that. It's fun to draw it and see, oh yeah, this does work out on paper and mathematically as well. All right. Here we have the distance formula, and for whatever reason I don't have the title. There it is, distance formula. Let's just get rid of that. Now, I stressed this today in class just really hard, that the distance formula is just the Pythagorean theorem repackaged. One of my students, Gary, hi Gary, if you're listening, said, well, why wouldn't you just use the Pythagorean theorem? It's easier. Yeah, if you have a coordinate plane. If you don't have a coordinate plane, the distance formula comes in handy. You should have this handy. You should really just have it memorized. x2 minus x1 squared plus y2 minus y1 squared, all of that under the square root symbol. That's it. It seems like, oh, I'll never do this, but you remember negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And if you don't, sing that song. It's a fun little song. At any rate, we're looking at the distance formula. Take a second, hit pause, copy this down because we're going to use it in a second. All right, here's where, hey, we could use the Pythagorean theorem, absolutely. And let's just demonstrate how the Pythagorean theorem works. Here is it's not a line. We're not trying to find the distance of this line. What we're trying to find is the hypotenuse of this right triangle. The hypotenuse always being the one directly opposite of the right angle. So I say, hey, well, how long is this A? This is A. Let's call this B. A is 1, 2, 3, 4, 5, 6, 7, and an 8. So that is 8 squared plus 1, 2, 3, 4, 5, 6, 7, and 8, 9, 10, and an 11. 11 squared equals c squared. And 8 times 8 is, of course, 64. Plus 11 times 11 is 121 equals c squared. I have to shrink this up. Bear with me. Move it over there in the corner. Continue with my mathematics. 64 plus 121 is 185 equals c squared. Again, the opposite of a square is a square root. And with my handy-dandy calculator, 185 square rooted is approximately 13.6014705, a whole bunch of digits, so we're just going to call it approximately, our hypotenuse is approximately 13.6. So again, there we are. That's exactly how we use the Pythagorean theorem. But let's say we were given the same numbers by themselves, not on the grid. And again, I'm just going to say 7, 5, negative 7, 5, and 4, negative 3. All right, if I'm given those numbers again, not on the grid, and I can't do my fancy handy little triangle, which is really the way I suggest doing it if it's given to you like that on a test, then I have to use the distance formula. And as you may or may not recall, excuse me while I shrink this up, as you may or may not recall, distance equals the square root, oopsie, got to get my pencil, the square root of x2 minus x1 squared plus y2 minus y1 squared. So x2, again, we have our smaller number, larger number, x1, y1, x2, y2. Again, so it's x2 minus x1 squared. So what is x2? x2 is 4 minus x1, which is negative 7. So that's the same as 4 plus 7 squared. And y2 plus y2 minus y1. y2 is our negative 3 minus 5 squared. And what we end up with here, and I'm just going to draw that square root symbol once, is 7, 8, 9, 10, 11 squared plus negative 8 squared. Wait a minute, that looks awfully familiar, doesn't it? Here's my 11 squared, and here's my 11 squared. Here's my negative 8 squared and 8 squared. Aren't the same thing, are they? Well, of course they are. Anytime you square, and you know, technically I need to have those in parentheses. Anytime you square a negative number, it always ends up positive. So I end up with exactly the same values here, 121 plus 64. All of that's still under my square root. That's 185 rooted. Bada bing, bada bang, same answer, 13.6, 185 rooted. So it's just the repackaged Pythagorean theorem, but you don't always have a coordinate plane to work with, so you might as well learn how to do it this way as well.